So up next, we have Daniel Campbell from Capvidia. He is the Vice President of Model-Based Definition at Capvidia. He has been working for over 20 years with major manufacturers on model-based definition and model-based quality implementation, and is active in the development of standards like the QIF format. I'd like to welcome up Daniel Campbell.
All right, thank you, Nasir. So that's right, my name is Daniel Campbell, and I'm going to talk today about model-based definition, and really what I'm going to be talking about is trying to give an idea about what are some very tangible steps that you could take to start to get into this area of model-based definition. So first off, a little bit about Capvidia. So Capvidia, we're a provider of technology, software technology in the space of model-based definition. Here's kind of an overview of some of our major customers. I think the important takeaway here is, typically we are working with the larger companies. There's the ones that are leading the charge when it comes to model-based definition implementation. And it really is across all verticals. Aerospace and defense is often what people think about when they think about model-based definition, but there's a lot of use of model-based definition in other industries as well. It really can help pretty much any manufacturing industry. The couple of software tools that Capvidia provides, a couple different families. One is our Capvidia family, which is the software that I'll be talking about today. We also have our Capvidia technology. I'm not going to be talking about that really, but basically what it is it allows you to compare two CAD models to determine what are the differences between the CAD models in terms of the geometry and in terms of the PMI. And so it's a separate application area, but it's useful for checking derivative CAD models to make sure that they match the native if you've done translation. Or maybe you have Rev 1, Rev 2 of a model, and you want to see what has changed between those two revisions. So it's for workflows like that the Capvidia software is used. But let's dive a little bit into the Capvidia software. So first, a little bit of background about model-based definition. So for those that don't know, what is model-based definition? What is it all about? So as we know, the typical process right now that's used for manufacturing complex parts is the CAD, or the part is designed in a CAD system, maybe NX or CATIA or Creo, SolidWorks maybe. And typically what's done is you have that 3D model, and then that 3D model will then be projected onto a drawing. And in that CAD system, you'll create a drawing. In the drawing, you'll add these annotations like you see here. And that has all of the engineering specifications, all the tolerances, everything you need to measure on the model. That drawing is then exported to a PDF. And then when you go downstream, you have somebody who might be in manufacturing, they'll get a CAD model, and then they'll get a drawing, a blueprint. And then they'll read that drawing, and they'll enter that data into whatever software they're using. Maybe it's CMM software. So the problem here is obvious. You have somebody entering data at the CAD system level, exporting it to PDF, and then having another human read that PDF and re-enter that data. The entire process really doesn't make a lot of sense. So model-based definition is about solving this problem. What it means is that all of this extra metadata, you might call it, should be part of the model. And it should be defined on the model in such a way that it can be read not only by the human downstream, but also by software tools. And this will prevent, a lot of the breaking of the digital thread that happens between the design stage and the manufacturing stage. The first use case that we're going to talk about today for this model-based definition, this use of model-based definition, is the simplest use case. And this is the first use case that most of our customers get into when we talk about implementation of model-based definition on a large scale. It is a big change, moving from a 2D drawing world to a 3D model with 3D annotations moving from one world to the next, it's a big change. And so it's not something that you can just, do all in one step. The way to do it is try to do it with small steps, prove the value as you go along. And so that first step that's typically done is generation of first article inspection reports. Seems like a simple thing, but so a first article inspection report might look like something right there on the bottom right, where basically what you're doing is you're going through the drawing. Let's say that we're looking at a drawing situation. You'd be going through the drawing. You would analyze all of the different annotations on the model that need to be measured. You'd balloon each of them, add little IDs next to each of them, and then you could transcribe each of those tolerances into a table. That's how it's done in the 2D world. And this is a great candidate for an early thing that you could do easily in the 3D MBD world that would gain, provides a lot of value and is relatively easy to do. And so before I kind of start explaining that first article inspection workflow, I'd like to give a really quick background on QIF, because I know a lot of people have asked about this. They've heard about this term QIF or this data format called QIF, but don't really know a lot about it. So what is it? Just very quickly, it's an ISO standard. It's ISO 23952. It's an ISO standard for transmitting data. So it's a data format for computer software. At its core, it's an MBD format, meaning that it's a CAD data format, including all the 3D annotations. So perhaps some of you are familiar with, obviously with STEP, but then there's STEP AP242, which is the flavor of STEP that's designed for 3D CAD data with the 3D annotations. QIF accomplishes that as well with its QIF MBD. But then on top of that, there's a whole set of other layers of data that can be stored in the QIF format. Especially, particular note is number 2 there, the plans, which is this high-level inspection plan. And then number 6 is also especially important, which is the results. And this is a mechanism for capturing as-built product data and storing it in an MBD format. So you have as-built data that's stored along with your MBD model. So that's a little bit of background about what QIF is. It's important because it's a standard. And so for all of you contract manufacturers out there, you're probably starting to see a lot of QIF data in your technical data package. And so if you're wondering what it is, well, this is what it is. So let's get into this, this use case about generating first article inspection documents. So in aerospace, a big one is the AS9102 form that has to be generated. The first step is you start with your native CAD model and you publish your neutral CAD data that will be used for the FAI, to create the FAI. So the native model, maybe it's a Creo model, maybe it's an NX model, a QIF model will be published for that. And so that'll contain the model, it'll contain the annotations, it'll contain all the saved views, it contains everything that's in the model. From there, we'll generate what's called the bill of characteristics. So the bill of characteristics is just basically the list of all of the annotations that represent something that needs to be measured, listed in a tabular form. And so you can kind of see it at the bottom of the screenshot there. It'll just kind of break it down into a table, a list of everything that needs to be measured. That's the bill of characteristics. And the next thing would be that you dump that bill of characteristics to an AS9102 report. Normally, this would be the end of this process of generating these AS9102s or these first article inspection reports. But the other step that we can do here in the MBD world is, like I was saying, capture that as-built data. So once you record those measurement results into the AS9102 form, you could import that Excel back into the MBD video software and store those results inside of the model itself. So you're really, capturing as-built data inside of the MBD model. So that's kind of an overview of it. What I'm going to show now is a video that shows, these 4 stages, so you can kind of get an idea of how it works on a real part. So our starting point is going to be, in this case, an NX model. So maybe, maybe NX is your native CAD. We have all our saved views, all our annotations. We're going to export that to the QIF format, this neutral standard format for data interoperability. And we can see on the left side is the QIF, on the right is the NX. All the saved views are there, all the annotations, etc. Next, we'll go and look at that bill of characteristics. So that's just a one-click button operation. We could automatically add the balloon numbers to the PMI, view that table, press another button, and we get that inspection report generated. These inspection reports can have saved views from the model embedded inside of them and things like that. Another useful thing that people are doing with 3D MBD is publishing viewable documents like this 3D HTML file that we're looking at here, where you can view this in a browser. It's an HTML file. You don't need to install any software for it. And it allows you to view the CAD model and the bill of characteristics in a browser. And you could rotate around and zoom in and zoom out and so forth. And it's a pretty useful utility in terms of, being on the shop floor and trying to fill out an Excel file. It's a great way to kind of help walk through that MBD. And then the final stage, we now have a completed Excel form that has all the results. We could import that back into MBDVidia and store those results inside of the QIF model itself. So what this means is now that Excel file that you had, you could save it for archival purposes or something like that if you need it, but really it's not needed in terms of really analyzing the data anymore. That can be stored inside the model. You can carry out SPC and other types of data analytics on that data that's inside of the QIF model. So it's just a quick view of this earliest MBD implementation stage that most of these larger companies that are getting into model-based definition, this is usually, like I said, one of the first things that is done, because as you can see, it's pretty straightforward. It's pretty easy to implement, and it does deliver a pretty big value at the end of the day. I believe these slides will be available later, and there are a couple of videos that you can download through these slides. Now, talking a little bit about this sort of incremental approach towards getting into MBD, starting small, starting with smaller pilots and easier tasks. It's also important to remember that you're not going to be able to snap your fingers and make 2D drawings go away. 2D drawings will be here for quite some time. If you're talking about the aerospace industry, probably forever. And so you're always going to be in an environment where you will have a mix of 3D MBD, but also 2D PDS. That's one of the reasons in our MBDVidia software we have the ability to handle both situations. So, this is a nice thing. I mean, what it means is that if you are kind of 1 foot in model-based definition and 1 foot in the 2D drawing world, you can use the same software platforms, the same sort of procedures in terms of generating your bill of characteristics and generating your inspection documentation. So that was the first use case, the first article inspection. There are a lot of other interesting use cases, and I'll just kind of jump through them real quick. Just kind of give a real quick overview of what some of those different use cases are. If you want to learn more about some of these different use cases, come on over to where we are or find us walking around, and we could talk about it a little bit more. The obvious one is coordinate metrology of all types, CMM, or maybe scanning. There are a lot of really cool devices around here. We have a CMM, obviously, an X-ray CT, an arm scanner, a blue light scanner. All of these things at the end of the day are point collectors. And you collect your points, you analyze them against the GD&T that's on the model. This is driven by the MBD, by the 3D annotations or the annotations that are placed on the drawing. So they're an essential part of driving a CMM type of workflow. So this is a big application area for model-based definition. There are applications of MBD outside of the realm of dimensional quality. There are certain non-dimensional inspection technologies that take advantage of annotations that are placed on the part. The thing that we're looking at on the upper left there is a camera-based visual inspection system that is able to read the QIF data that we publish to automatically generate these robot paths and camera angles and illuminations and all this stuff from visual inspection requirements that are placed on the model. So we could export that data in QIF, they'll do all these calculations, create the robot path, execute it, and then it'll be able to automate these things that are otherwise often done by humans. Another big area is welding. This is out of quality entirely, into a totally different area. But welds obviously are specified typically on a drawing, but there are mechanisms in the CAD systems to specify these as 3D annotations as well. There are systems like these weld robotics systems that can automatically generate weld programs. And why would you print that out to a PDF to have someone digitize that into the weld software to generate the program? It's better just to read that file directly and have the weld software read the 3D annotations in the model and automatically come up with the path. So that type of stuff could be done. We're doing a lot of work in terms of generation of work instruction documents from the PMI, things like that. So it's really not even just quality that there are a lot of applications for MBD in. Although quality probably is one of the primary areas, there are other areas in manufacturing that will take advantage of model-based definition. I guess the last thing is, here's an example of a workflow that we had demonstrated just a few weeks ago, about a month ago at IMTS in Chicago. And we have a video for this. Again, if you get these slides, you can see this. But I'll just kind of explain the workflow, which is kind of a sort of a classic, MBD-based workflow. So we'll start with that native CAD model. In this case, it was an NX model. We'll publish that to the QIF format. We load that in MBDVidia. We'll balloon it, generate that bill of characteristics and add the balloons, generate the high-level inspection plan. And what I mean by that is that we had various different characteristics on the model that needed to be inspected. Some of them were going to be inspected with a Faro scanning arm that we had. And the data was going to be evaluated in Polyworks. Some of the data was visual inspection data, and some of the data was sort of general pass-fail type characteristics. And those were all going to be routed to different areas where we had some of the characteristics were measured in Polyworks, like I said. Some of them were measured through some type of a general inspection use case. And then the final thing was this visual inspection with the robot. So it kind of split up there, but then the results from all three of these different inspection areas were gathered back into the original QIF file, so that we had all of the results from the various areas stored into that single source of truth. And again, if you want to see that video, check out these slides later. And just, some closing notes, a little bit about some anecdotes that we've gotten from some of our users in working with them on their MBD implementation. So the first one, an aerospace and defense customer working on first article inspection report generation. This was a generation of AS9102. They were spending about 15 to 20 hours generating this document. With the initial implementation of our software, it took them down to 2 hours to generating this. And actually, at that point, there was still a lot of refinement that could be done. It was a really quick and dirty implementation that they did. So it gives you an idea of why I was saying the first article inspection report generation is a real low-hanging fruit. In the consumer goods industry, one of our users was seeing about 60% time savings on their PPAP process by automating all their inspection documentation through MBD. And then in the automotive area, there was a user that was carrying out coordinate metrology, CMM measurements, and on a production part, they took the processing time from 8 weeks to 6 weeks through this process. So which is a pretty big gain for automotive. So it's just kind of a little sampling of some of the ROI anecdotes that are out there. And with that, that's all I have. If you have any other questions about model-based definition or about Capvidia software, please come by and just ask.